Alright, hey guys, welcome to part 2 or lecture 2 of this weekend SSA. So we just got done with finishing Flappy Bird and we learned all about objects and kind of what they are and why they're important, okay? So there's the Flappy Bird object, there was the ground object, the pipe object, etc. Now we're going to learn how to manipulate objects, okay? How to do things with objects. And the main way we do that is through the use of functions, okay? So what are functions? Functions are just blocks of codes that can do things, okay? So that's super vague, but they can do things to objects in many cases, or, I mean, you'll get a hang of it. You'll understand what functions are. But we see functions in other applications like math, right? So we have f of x equals x squared, and what is that saying? Well, when x, right, when x comes in, this is what comes out, okay? So when I put 5 in, 25 is going to come out. There's some computation done on x by f of x, which is this rule, and the output is 25. And the same idea can be applied to functions, right? We're going to take in something, we're going to do some stuff with it, and we're going to output something, okay? And so functions in our code basically take in, an object and do something with it, or they can take in nothing at all and they can make, calculations or do some outputting to the screen or, change the state of our game, that kind of thing. They can do different things, but they usually take in something. They can also not, but they always perform some kind of calculation on whatever comes in and change something, okay? So what are the functions in Flappy Bird? Let's just kind of think about that for a bit. Well, functions are called. So let's brainstorm. So what function was called when you clicked on the screen or pressed the space bar? What happens when you click on the screen or press the space bar while playing the game? Okay, pause the video for a sec. Consider that. Yeah. Okay, so basically what happens is we get a flap. Okay, so the function is flap, and it usually is going to take in like the bird. So it'll take in the bird, it'll make the bird flap, and what is that flap going to do? It's going to make the bird like fly up a little bit. It'll probably trigger some sounds. It'll change something. It'll do things on that object. Okay? What function was called when you hit the ground? What happens when you hit the ground or pipe? Think about it for a sec. Okay, pause again. Alright, so what happens when you hit, the ground is the game has to exit. It's over. The game basically crashes. So what I would do is I would call that function crash. And whenever your bird object hits your pipe object or hits your ground object, what I would do is I would say, okay, that is, a crash. And I would call this crash function. And things would happen. What things would happen? Well, the game would exit. It would also like print out the score that you got, that kind of thing. Okay? Okay. And so this brings up the idea of abstraction, which is this idea that the function always does what it's supposed to do, and we don't really need to like worry about what's going on underneath the hood. So what's going on behind the scenes, okay? The function is doing something, okay? We know that. When we, click, we get a flap function. When we crash, we get a crash function, okay? And it's handling events and it's doing things. We don't really need to know about like what's going on like underneath the code behind the scenes, okay? What we do need to worry about is what the function is doing. So what is it doing? It's causing a flap, okay? So in that way, function names and documentation, which tells us, what a function is designed to do, they're really important, okay? And so I'm going to do a quick demo with Python, which is what we'll be using in the week-long class. But don't worry, you're not expected to know anything. I'm just going to show you guys a function. So this is a function. I've named it mystery, okay? And it does a bunch of stuff. Take a look at this. If it makes any sense at all to you, great job. You're on an awesome track. But basically, I'm going to call this function. That's what these are. We're calling the function, and 3 and 3 are basically coming in as x and y. And then it does a bunch of stuff, and it returns an output. So something comes in, something comes out, a bunch of computation in the middle. Okay? So what should happen when I do this? We get 9, 9, and negative 9. So if you notice, what did I do? 3 times 3 is 9. 3 negative 3 times negative 3 is also 9. And then negative 3 times 3, there's only one negative in there, is negative 9. Okay? So that's what happens here. So a better name for this would actually be multiply. And it takes in 2 arguments. So I'm going to write this in a comment. It takes in 2 arguments and multiplies them together. Okay? And this looks like really, complex code, and it really is. Like, I could have done this multiply simple. Takes in an x and a y. Return x times y. Okay, that's a simpler version of all this code. Okay? So this is an example of a function that takes in things, does a bunch of computation, and then returns like a new output, okay? And this output, in these cases, for these arguments, is them multiplied by each other. Okay, and so in our abstraction of Angry Birds, which is the hour of code activity we'll be doing next, each command is actually being backed by actual code underneath the block. So, for example, the click event triggered a flappybird.flap function call, which caused stuff to happen. Okay, we don't really care how it happened. We just care that the stuff happened, that it flapped. Okay, and so some other brief, quick questions to consider. So we're going to do a quick introduction to loops. So loops are basically a way to get from point A to point B. In the game, they allow you to repeat commands so that you can move your bird from point A to point B. But in real-world code, loops allow you to repeat some computation until you reach the end or some desired result. Okay, so I can loop until I get to something that I want. Okay, and you'll get to practice with loops. Don't worry. And then one hint, because there is a hard part. Puzzle 9. Loops can have loops within them, so just look out for that. Okay, loops can have loops within them. So if you get stuck, just remember that loops can have loops within them.